Good evening, ladies and gentlemen. Am I coming through okay?
Yes.
All right, we just got one. Well, let's see. Yeah, we just have one section to do, ladies and gentlemen. This is involving applications or word problems in section 2.6. And as a result, we're going to be going using our book quite a bit today. So we'll begin by going to our textbook and looking at page 141. All right, so this is section 2.6 applications. First of all, on the bottom of page 141, they kind of like give you some guidelines as to how to approach or how to attack word problems in general. It's step number one says read the problem. And then it's wise to mentally list the items that are known and the items that are unknown in the word problem. In other words, it's always wise to document on your paper things that are given to you in the word problem. Number two, it says assign a variable to one of the unknown items. In most cases, this will amount to letting X represent the item that is asked for in the problem. So whatever it is we're being asked to solve for, normally we declare it as the variable X. Then we need to translate the other information in the problem to expressions involving X. So step two involves the declaration part of a word problem, ladies and gentlemen, where you declare your unknowns as a variable or a variable expression. Once we do that, then oftentimes we have to go back and reread the problem and eventually, hopefully, are able to set up an equation involving our variable or variable expressions we declared back in step two. Once we set up the equation, of course, we then solve the equation. And it would be wise to write your answer using a complete sentence so that you clearly understand what the answer represents in the context of the situation that we were immersed in. All right. Okay. So now we're going to go to page 148. Hold on a second. Page 148. Okay, page 148. All right, we're going to try to do some of these even problems here. Now, the instructions say on page 148 to problems 1 through 8, it says translate each sentence into an equivalent equation in symbols. So we're going to read some words here, ladies and gentlemen, and it's going to be our job to convert these words into an equation that represents the situation. All right, so problem number 2, it says the difference of X and 4 is 8. How would we write that as an equation? Problem number 2.
X minus 4.
Okay, so the difference is a key buzzword that represents subtraction. And so that's something that we want to address. In fact, maybe we should look at some of these key words before we get into those problems. So let's come back here and let's look at a couple key words here first. All right, so we will call these key words that clue us into the type of operation that we're going to be expecting to deal with. Ladies and gentlemen, what type of words would suggest that we are to add things together? Can you think of any words in a word problem that would suggest that?
Sum.
Yeah, finding the sum obviously means addition. Any other words that you might think that might clue us into addition? Sum is a big one. That's an important one. Hey, how about to total things up? If they want you to total things up, like when you go to the grocery store, you total up your bill, correct? That's adding all the items together. So to total something means to add things together, sum, and those. Okay, how about subtraction? Any keywords for subtraction?
Difference.
Difference. If you're being asked to find the difference between two numbers, that means subtraction. Any other key words or phrases for subtraction? Difference. Difference is a big one. How about this? How about less than? If you see less than, or if you see less or less than, all suggest subtraction. These all, minus, of course, that's very explicit there, minus. Okay, any idea for like multiplication? Keywords for multiplication.
Product of.
Product, yeah. The word product means multiplication. The word of, when you see the word of, that means multiplication. Like if you're gonna take 1/2 of 10, that means 1/2 times 10. Okay, product of, these all suggest multiplication. How about division? Any keywords for division? Product of.
Is it quotient?
Quotient. Yeah.
Keyword?
Yeah, quotient. When you see this word quotient, that means division. Okay. Quotient, divided by, obviously. That's pretty explicit there. Okay. Per, believe it or not, per means division. Like if you get in your car and you drive 50 miles per 2 hours, that means you're driving at a speed of 25 miles per hour. Do you agree? Per means division. 50 divided by 2, 25. Okay. All right. So all of these are, kind of like buzzwords. Another one for addition that just struck me is when you see the phrase more than. Whoops, more than. If you see more than, it means add. Ladies, for subtraction, decrease. To decrease a number in value means to subtract something off from it. Okay, to decrease.
Plus for addition.
Yeah, plus.
Or added to.
Added to, all these are very explicit, obviously, these plus, added to. I mean, that doesn't get more explicit than that. All right, so I think that that's good for now. Now, so that first problem, number 2, said, how did it read? It said the difference of x and 4 is 8. Okay, the difference of x and 4 is 8. What would that suggest? Well, for number 2, difference means what? Subtraction. The difference of a number x and 4 is 8. It would suggest x minus 4 or x subtract 4. Is means equals, ladies and gentlemen. When you see the word is, or you see the words amounts to, something amounts to, these all mean equal. So that would be the equation that we would want to set up for problem number 2 there. The difference of a number x and 4 is 8. Okay. Another way you could name this is to say 4 less than a number x is 8. That would be another way to name that equation. 4 less than a number x is 8. Okay, or you could say a number decreased. A number decreased by 4 is 8. That would be another way to name that equation. Okay, so all of these work here. So the difference of a number x and 4 is 8, or 4 less than a number x is 8, or a number decreased by 4 is 8. All those are valid ways of representing that equation. That makes sense? Number 2. Let's go on and see if we can do a number even one here. Number 4, it says the quotient of x and 2 is equal to the difference of x and 4. First of all, quotient of x and 2. How would we write the quotient of x and 2?
X divided by 2, or
Yes, yeah. You could say x divided by 2. And do you agree we could put x over 2 as a fraction? The fraction bar means division, doesn't it?
right?
X over 2. So the quotient of x and 2, that's x divided by 2, is equal. That's pretty obvious. That's the equal sign. Is equal to the difference of x and 4. How do we represent the difference of x and 4?
Subtract.
Yeah. What order? Would it be 4 minus x or x minus 4?
Would it be x minus 4?
Yeah, it probably would be x minus 4 in this case. Okay, the difference of x and 4. If they said the difference of 4 and x, then it would be probably 4 minus x. But because x comes before 4, yeah, I'm thinking difference of x and 4 is x minus 4. All right, so anyways, this is what we would have for number 4, ladies and gentlemen. The quotient of a number x and 2 equals the difference of a number x and 4. There you go. See how we're translating words into equations here? Let's try another one. Number 6. 3 times the sum of a number and 6, when decreased by 4, gives the result of 20. This one's got a lot going on with it. Anybody want to take a stab at this one?
What number did you say?
Number 6. 3 times the sum of a number and 6, we'll call the number x, by the way, when decreased by 4, gives a result of 20. How would we write this as an equation?
3x plus 6.
Okay, now notice it's saying 3 times what? The sum of a number and 6. How would we write the sum of a number and 6 first? Maybe we should do that first. The sum of our number x and 6, how would we write that? X plus 6. The sum of a number x and 6 is x plus 6, but then it says 3 times that sum, ladies and gentlemen. You know what this is screaming for, although it's not really explicit in this word problem, is parentheses. It's saying 3 times our sum of a number and 6 when decreased by 4. What does it mean to decrease a quantity? What operation?
Subtract.
Decreased by 4 means subtract 4. Gives a result of, in other words, equals 20. And, you know, number 6 would probably warrant this equation right here. 3 times the sum of a number and 6 when decreased by 4 amounts to 20. Okay. There you go.
You gotta make sure you have that parenthesis right there. Otherwise,
Yeah, it is. It's a subtlety, but it really is implying parentheses here because it's saying 3 times the sum. Look at, if you write this is saying something entirely different than what this above is saying. This is saying 3 times just a number. Do you agree?
yeah.
Added to 6 when decreased by 4 gives us 20. So we got to be careful. It's saying 3 times the sum. The sum should be this entire quantity inside the parentheses. 3 times this quantity called the sum. So yeah, parentheses really are needed there. I know it's not extremely explicit there, ladies and gentlemen. It's a subtlety, but parentheses are being warranted for that problem. Okay, that would be number 6. Number 8, it says 1/3 a number added to 1/2 the number equals 2 less than the number. How would I write this as an equation, number 8? 1/3 a number. How do you represent 1/3 a number X? How do you write 1/3 of X? What does that mean? 1/3 of X.
Is it 1/3 times X?
Yes, I kind of gave it away. Of means multiply. So 1/3 of X means 1/3 times X. So 1/3 of a number X is 1/3 X added to, meaning plus, added to 1/2 of our number X. How do we represent 1/2 of our number X? That would be 1/2 times X equals 2 less than the number X. How do we write 2 less than our number X? Is it X minus 2 or 2 minus X?
It's 2 minus X. 2 less than the number X?
Yeah. How would you write that? 2 less than the number of X.
2 minus X.
Okay. All right. So we got to clarify that or else we're going to be in trouble. All right. Let's say here. If I say 3 less than 5, you know what this is suggesting? It's got to be 5 minus 3, ladies and gentlemen. 3
Yeah.
less than 5.
Okay.
Now look at, if it says 3 just less 5, 3 less 5. That's different. This would be 3 minus 5. Subtraction's tricky because order makes a difference. So we got to be careful with subtraction. So when you got less than, the number that comes before less than goes after the subtraction. The number that follows less than goes before the subtraction. Be a little bit careful with less than. Okay, because that is a common mistake. So how do we say 2 less than our number X? 2 less than X. How do we write that?
X minus 2.
X minus 2.
Yeah, it's got to be X minus 2. 2 less than X. Let's go back and make sure that's what it was reading there. It says, yeah, 2 less than our number X. 2 less than X should be X minus 2. That is correct. And so, ladies and gentlemen, this would be your equation that we would have to write for number 8. 1/3 a number added to 1/2 a number equals 2 less than the number. All right, do we see how we're cranking out these equations for these words here? Translating words into an equation. Not always the easiest thing to do, but we need to try to come to grips with this because this is obviously something that we're going to need for this section here. All right, let's move on down. Let's see what else we got here. Let's try to do a couple of these problems in here. The type of problems that I do are the ones that you're going to be responsible for. So I'm going to do problem number 10 now. Now in these problems, it says solve the following word problems. Follow the steps given in the blueprint for problem solving. In other words, those guidelines we looked at in the past there. All right, so we'll try to do number 10. It says the difference of 10 and a number is -8. Find the number. So not only do they want us to set up an equation, but then they want us to solve the equation. So we're doing 2 things here. First of all, help me translate the difference of 10 and a number is -8. How would I translate that into an equation? The difference of 10 and a number. Let's call our number X, by the way. Let's just say let X be a number. Now, how would I translate that into an equation? Anybody?
Is it 10 minus X or X minus 10?
Well, let's see. We got to get that straight because obviously there's a difference. It says the difference of 10 and a number. Now, this is not the phrase less than. It's not the phrase less. It just says the difference of 10 and a number. So when it says just difference of 10 and a number, it will be 10 minus the number X. All right, so when it says difference of 10 and a number, it's 10 minus X. If it said 10 less than the number, that would be X minus 10. But this just says difference of 10 and a number, so we will have 10 subtract X. Is means what symbol?
Equal.
Equals. So is -8. Find the number. All right, so here we go. We have translated those words into an equation. The difference of 10 and a number is -8. And now they want you to find the number. So ladies and gentlemen, how do I solve this equation for X? How do we solve for X? Anybody?
add, or I mean, yeah,
What would you add?
10 plus
Would you-
-8.
Oh,
Would
okay.
you add 8?
Add
Then
8.
Positive.
Now, if you add 8, you're gonna bring the 8 over to the left, and we're gonna have everything on the left side
Right,
equal to 0. I got a question. What signs in front of the 10
Subtract
here?
10 from both sides.
Yeah, notice it's understood that this is a plus 10. It's understood. Ladies and gentlemen, how would I move this positive 10 over to the other side to join the -8 as I separate the variable terms on the left from the constants on the right? How do I move
Oh,
the
you
positive?
subtract it.
Subtract it. So here we go. We're going to subtract 10 from both sides. Now these 10s on the left side cancel out to 0. They add up to 0. They're gone, leaving us with -x.
And
And
x equals -18.
Yeah, -8 subtract 10 is the same thing as -8 plus a what? -10, which will give us a -18. Now we're almost done, but this x is not by itself. -x is really understood to be like -1x. So how do we make this -1 factor go away? How do we do that? Yeah, we would divide or multiply both sides by a -1, in which case we would have 1x now, which is just x, right? -1 divided by -1, and that's equal to +18, and we're done. So the unknown number for problem number 10 that they wanted us to find is 18. So there's two problems we're confronted with now in these particular exercises. First, we have to set the equation up. Secondly, we have to then solve the equation, okay? So two things. Any other questions about number 10? Does that make sense? How we first set up the equation and then how we solved it. All right, so that one's good. Let's see what else here. All right, we'll try one like number 12. It says the difference of 4 times a number and 8 is 16. Find the number. Again, we'll let the number be x. In fact, for all of these problems, we'll just let the number always be x here. So how would I set up an equation that translates those words? The difference of 4 times a number x and 8 is 16. How do I write that as an equation? How would I write that as an equation? Difference means what?
Difference means subtract.
Subtract. Okay, so the difference of 4 times a number. How do I write 4 times my number x?
4, and then you put the x inside the parentheses.
No, we can just say 4x because all it's saying is the difference of 4 times a number. It's not saying 4 times a sum or 4 times a difference. Do you agree? It's just saying 4 times our number x. That would just be 4x. So the difference of 4 times our number, which is 4x, and 8. So the difference of 4 times our number and 8 is what? 16? This would be the equation that we need to set up. It's saying the difference of 4 times a number and 8 is 16. The difference of 4 times a number and 8 is 16. Now, how do I solve for x here?
Add 8 on both sides.
Yep, so we'll add 8 to the left, we'll add 8 to the right. The 8's dive out on the left to 0, leaving you with 4x. And 16 plus 8 on the right is 24. Now what do we do?
Divide by 4.
Divide both sides by 4, and I think we got x.
6.
This reduces down to 1. 1x is just x. X is equal to 6, and we're done. And that's the answer to number 12, okay? So first set the equation up and then solve the equation. Any further questions about number 12? All right, number 14. 5 times the difference. Notice it says 5 times, not a number, but it says 5 times the difference. What is that suggesting, ladies and gentlemen, if it says 5 times the difference? What symbols must we have in our equation? 5 times a difference.
Parentheses.
Parentheses. Very important. That is implying the use of a parentheses here. 5 times some sort of a difference, which will be inside our parentheses. So 5 times the difference of what? Twice our number x and 6. How do we, first of all, just represent 5 times the difference of twice the number x and 6? How do we just write that part?
5 parentheses.
So wait a minute, why do you use, okay, wait a minute, now I'm lost. So why are you using the parentheses on this problem and not your last one?
Okay, because the last one, it said 4 times what? A number. It did
Oh,
not-
okay,
It
I
did not
see, I
say
see.
4, it did not say 4 times the difference or 4 times the sum. It didn't say that.
Okay,
It's a subtlety, okay? So 14, though, it says 5 times the difference. It doesn't say 5 times a number. If it said 5 times a number, it'd be 5x, do you agree? No,
okay.
it doesn't say that. It says 5 times the difference. This difference should be inside parentheses. So 5 times a set of parentheses. And what
Two.
goes in my parentheses?
2x plus 6.
Okay, careful. It says 5 times the difference of twice a number and 6. What's the difference of twice a number and 6? Is it 2x plus 6 or 2x minus 6?
2x minus 6.
Yeah, difference means subtraction. Okay, so 5 times the difference of twice a number x and 6. So what that's going to warrant here is 5 times the difference of twice our number x and what? 6. 5 times the difference of twice our number and 6. All right. All right. And let's read on now. It says, okay, 5 times the difference of twice a number and 6 is means what? Equals negative what? Negative 20? So this would be our equation now we have to solve. 5 times the difference of twice a number and 6 is negative 20. Now help me solve this for x. How do I do that?
Distribute.
Yeah, we have no choice. Well, I mean, we really should distribute on the left side to remove these parentheses. So 5 times 2x is 10x. 5 multiplied by a negative 6. 5 times a negative 6 is a what?
Negative 30.
Minus 30 equals negative 20. Good. Now, how do we solve for x?
Add 30 on both sides.
Yep, it's time to separate the variable terms on the left from the constants on the right. To do that, we will move the 30 over to the right by adding it to both sides. The 30s drop out to 0 on the left side, leaving you with 10x. On the right, we have negative 20 plus 30, which should be a positive 10. Finally, ladies and gentlemen, how do we get x by itself? We
5 by 10.
Yep, we divide the left and the right side by 10. The 10s reduce out to 1 on the left side. 1 times x is just known as x. And 10 times 10 divided by itself on the right side is 1. Looks like your solution is 1. That would be the number they wanted us to find. X equals 1. All right, so setting the equation up obviously is a little bit of a challenge. And then we have to solve the equation, which, you know, has 2 things going on with these problems here. All right, let's see what else we got going on here. Number 16. Now, ladies and gentlemen, this is a little bit more of a complicated one. Number 16, it says one number is 3 less than another number. Their sum is 15. Find the numbers. Notice we're going to have more than one answer now because it says find the numbers. How do we begin to do a problem like this now? This one's different than the other ones. It's a little more complicated. All right, so problem number 16. How many answers are we going to have to this problem when we get done?
2.
We're going to have 2 because there's 2 numbers involved. It says one of our numbers is 3 less than another number. All right. I have a question for you. The way this reads here, ladies and gentlemen, which number depends upon which number? It looks like this first number, which you're calling one number, depends upon what? The value of the other number. They're calling another number. Because of that, we're going to have to let x, we're going to first of all declare x to be equal to another number. So that's the first thing I'm going to write on my paper. I'm going to say let x be equal to another number. Okay. Now, so I have a name for my other number. It's called X. Do you agree? Because that's how I declared it. Let X be equal to another number. That's all I wrote on my paper so far. But what does it say about our first number though? How does it relate to this other number? Well, it says our first number, which is one number, I'm calling my first number, is 3 less than our other number. How do we represent 3 less than our other number that I am calling X? How do I represent 3 less than this other number X?
Minus.
Yes, it would be X minus 3. So ladies and gentlemen, 3 less than one of our numbers is 3 less than another number. If I'm calling my other number X, then X minus 3 must be my first number. Is that making any sense right there?
Yeah, a little bit.
It says one of our numbers has to be 3 less than what? Another number. Do you agree? If I call my other number X, then the first number has to be X minus 3 because it says it's 3 less than the other number. So we'll call this then, I don't know, maybe call it the first number or something. All right. So we have 2 numbers that have been declared. Ladies and gentlemen, the first number is X minus 3 and the other number is X. What does it say we're going to do with these 2 numbers? Let's read it again. It says one number is 3 less than another number. Now it says here in the second sentence, their sum is 15. What does it mean to sum up these 2 numbers?
Add.
That's right. The sum of these 2 numbers is 15. So we're going to add these numbers together. And their sum better be equal to 15. There is your equation. So the recap, it says one number is 3 less than another number. If the sum of these 2 numbers is 15, now we'll find the 2 numbers. How do I solve this equation for X?
Combine like terms.
Like terms, 1x plus 1x, 2x. Okay, now we got to what? Separate. Do you agree? Variables on the left, constants on the right. To do that, we'll add 3 to both sides. 3's drop out on the left, leaving you with 2x. 15 plus 3 on the right is 18. Now we divide both sides by 2. And what's x? X is 9. But wait a minute, I thought we had to add more than one number. Well, ladies and gentlemen, X is the number I'm calling the other number. Do you agree? What's my first number? What was the name of my first number? How did I declare it? It said my first number has to be 3 less than the other number, which is 9. So what's our other number? What's our first number going to be? It's going to be X minus 3, which is the same 9 minus 3, which is what? 6. And we're done. We have our 2 numbers. Our numbers are 9 and what? 6.
So you have to, after you get your 9, you have to take the, you have to go back up and take the X minus 3.
That's right. Because they wanted 2 numbers, correct? We found the first number, X, to be 9, but they want the other number too. Well, the other number, remember, was 3 less than what? This number, correct? So 3 less than 9 gives us our other number, which is 6. Yeah, there has to be 2 answers for that problem. Because they wanted to they said find the numbers. All righty. Yeah, that was a little more complicated. What made this more difficult is, first of all, declaring our unknown numbers as variable or variable expressions. This part of your word problem is step number 2 in those guidelines I read to you to open up tonight's session. This is called your declaration part of your word problem, where you declare your unknowns as variable or variable expression. Yes.
Okay.
This is a very important part of any word problem, declaring what it is we're being asked to find as variable or variable expressions. A very important part of a word problem. Okay. But it can be at times one of the more difficult parts of the word problems, unfortunately. But it's a very important or an integral part of getting any word problem correct, is declaring your unknowns, correctly. So that is very important, that part. All right, that was one like number 16. We can try number 18. It says one number is 5 more than twice another number. If their sum is decreased by 10, the result is 22. Find the numbers. All right, to begin this problem number 18 here, first of all, I would recommend we just let x be equal to some number. Let's just declare x to be equal to some number. So now we have a name for one of our numbers. It's called x. But it says another number is 5 more than twice our first number, if you will. So if I'm calling x my other number, or just calling it some number, how do we represent the other number? By writing a variable expression. If
X
the other
plus
number,
5?
what's that?
Is it x plus 5?
Yeah, it says the other number must be 5 more than twice our number x. So how do I represent 5 more than twice our number x?
Five.
times 2 plus 5.
Yeah, 2x plus 5. So 5 more than twice our number x is represented this way. Come on, I don't know what's going on here. Hello, can you hear me? All right, sorry about that. All right, so 5 more than twice our number x is written as a variable expression. So ladies and gentlemen, this will be a variable expression that represents the other what? Other number. So we have properly declared our two numbers. One number is called x, the other one is 5 more than twice that number x. What are we going to do with these two numbers? What does this say we do? It says if there's sum means to what?
Add.
We got to add these numbers together. Okay. So it says if the sum of these two numbers, meaning we add the two numbers together, if the sum of these two numbers is decreased by 10, the result is negative 22. There's your equation. If the sum of the two numbers that were declared up here is decreased by 10, then the sum is negative 22. That would be the equation we had to set up here. The toughest part is declaring your numbers, first of all, declaring them properly as variable or variable expressions. One of our numbers is called x. The other number is called 2x plus 5. If the sum of those two numbers is decreased by 10, the result is negative 22. We need to solve for x. Was it negative 22? Did they have to be equal to negative 22? I think so, yeah. Okay, so how do we solve this equation for x here?
Combine the like terms.
Yeah, simplify the left side. 1x plus 2x is 3x. Combine like terms of numbers. 5 minus 10. 5 subtract 10 is negative 5 or minus 5. That's equal to negative 22. What do we do next?
It's positive 22, not negative.
Is it really? I thought it
Yeah.
was negative 22. It
says the result is 22.
Okay, positive 22. Thank you. All right, anyways, we're going to add what? 5 to both sides now? 5s drop out on the left. So we have 3x is equal to 22 plus 5 is 27. Divide both sides by 3 and we get x is equal to what? 27 divided by 3 is 9. Are we done? Our number is 9. Careful. I think they were asking for what, both numbers, weren't they?
Yeah,
It
you
says
need another
find,
number.
yeah, find the numbers. We're not done. We got to find the other number. 9 is the number we're calling x. The other number is 2 times x plus 5. So our other number is going to be 2 times our number x plus 5, which is to say 2 times 9 plus 5. This is your other number. Now 2 times 9 is 18, and 18 plus 5 gives us our other number, which is 23. These, ladies and gentlemen, are your answers, your two numbers for that word problem, 9 and 23. Okay, those are the two
Do
numbers.
we have problems like this similar on the test or the quiz?
Well, I mean, we may have a couple of these, sure. I'll give you practice, don't worry. And I also give you the solutions to your homework so you can check your answers, correct? And check and see how they do them. So I'll give you the solutions to these word problems when I assign them also.
When we do the exam, are we gonna have like a review session before it?
Well, either that or I will give you like a like a review, you know what I'm saying, to get you ready for the exam.
All right.
All right. So I've done some of these even problems here, problems 9 through 18. And you know, I'll probably have you do the odd problems in here, okay, which are very similar. So you can do those. Okay, let's see. So we did that. All right, so Les Alman, in fact, classwork number 1 here, what I would like you to do is for classwork number 1 is I would like you to do problems number 11 and 15. So see if you can do 11 and 15 for classwork number 1, number 11 and number 15. All right. So today is the 29th day of September. We're going to do 11 and 15. Page 148. These will be 2 of your homework problems anyway, so we're basically going to take care of a couple of them right now in class. So see what you can do with those, 11 and 15. How are we coming on these word problems? Anybody need more time? Anybody got number one? Anybody want to give us the answer to number one?
I said it was x equals 3.
Okay, X
Got
equals
3
3.
too.
Anybody else get 3? For number 11.
I got x equals 5.
All right. The sum of twice a number and 4 is 14.
I got 5 too.
Find the number, okay. The sum of twice a number is 2x, do you agree? And the sum of twice our number x, 2x, and 4 would be written as 2x plus 4 means equals 14. So seems to me like this equation would have to be what? 2x plus 4 is equal to 14? It's saying the sum of twice a number and 4 is 14. And then when you solve that equation, you subtract 4 from both sides first. Then you divide both sides by 2 and you do get what? You do get 5. So 5 looks like it would be the correct result, ladies and gentlemen. All right, how about number 15, problem 15? One number is 2 more than another number. Their sum is 8. Find both numbers. Anybody get that one? Number 15. First of all, you want to declare your numbers correctly. So you could say like, let X be, some other number. And therefore the first number is 2 more than that. So X plus 2 represents the other number. So you got 2 numbers, X and X plus 2, because one of the numbers is 2 more than the other number. That's what it says. And it says you're going to add those numbers together. And when you sum those 2 numbers up, the sum should be what? 8. That looks like your equation there. Now we solve for X. Simplify the left side by combining the X terms, subtract 2 from both sides, divide both sides by 2, and you get what? One of the numbers is 3. What's the other number? X plus 2 or 5? So we got 2 numbers, 3 and what? 5. Anybody get those?
Yes.
All right, congratulations.
Can you go back up to the first one, number
Yeah.
11? Can you explain that wording again for me?
All right, the first number 11 here. Number 11 says the sum of twice a number and 4 is 14. So it says the sum means add, the sum of twice our number X and 4 is what? 14. See that there?
Uh-huh.
And that would be our equation.
So I'm thinking it's talking about parentheses.
Okay, now, if they wanted parentheses, then they would have to word it this way. They would have to say, twice the sum.
Oh.
Twice the sum of a number and 4. It's not saying that, it's saying the sum of twice our number, which is 2x and 4. So that'd be 2x plus 4. Yeah. Yeah, for parentheses, it would have to say twice the sum of a number and 4, something like that. Okay.
Okay.
I know it seems like these are saying the same thing, but they're not. They are some subtle but very important differences. Okay. So yeah, what's that?
On the second one,
Mhm.
even if we use 3 and not found the second one, it would still equal that. 3 plus 3 plus 2 still equals 8.
Yeah. Well, let's see here. Yeah, I mean, you're right. I mean, 3 plus 3 plus 2 is 8. You're correct. But they said one of the numbers was what? 2 more than the other number, though. You know what I'm saying?
Because if we plug in 5 and 3, it doesn't equal 8.
Let me hold on. Let me go back and read this here. Number 15. One number is 2 more than another number. Okay. Their sum is 8. Find both numbers. Okay, now. Okay, when you plug 3 back in, it works. Do you agree? 3 plus 3 plus 2 is 8, correct?
Yes.
That's because 3 is equal to x. But 5 is not equal to x. 5 is equal to what? X plus 2. 5 is equal to x plus 2, which means you don't put 5 in for x. 3 is equal to x. 5 is equal to what? X plus 2. So what would I have to put in for x plus 2 here? What's another name for x plus 2? 5?
Mm-hmm.
5 would have to go in for x plus 2. What's another name for x?
3.
3. Do you agree? 3 plus 5 does give you what, 8? Okay, yeah, so be careful there. X is not 5. X plus 2 is 5. X is 3, okay? Yeah, so the two numbers would have to be 3 and 5. All right, so that'll be classwork number 1. All right, now, ladies, I'm going to show you some examples of what are called age problems here, okay? These are different types of word problems. In fact, you got all different types of word problems. The only way you're going to get good with these word problems is by seeing them done and then trying to mimic what I do. You need to try to emulate that with similar problems. That's how we learn how to do word problems. It does take time to get good with word problems. It took me years to perfect my word problems, okay? But you have to start somewhere. And that's why they want you to start in elementary algebra here. They want to at least expose you to these so that if you do, go onwards, you will then be more proficient because you will have seen these done. All right, so you got to start somewhere if you're going to learn something new. Because if you never start anywhere, then you never will ever, learn how to do these. All right, number 20 says Carrie is 9 years older than Dan. In 7 years, the sum of their ages will be 93. Find the age of each man now. All right, to do these age problems, oftentimes a table is very valuable because a table helps to organize information that they provide in the word problem. Tables are not only good for age problems, they're also good for many other types of problems, such as rate problems, solution mixture problems, et cetera, okay? So we're going to try to do this age problem here. Notice, ladies and gentlemen, we have now versus what? 7 years from now. Do we agree with that? Now versus 7 years from now. So we got now, we have a column that represents now, and we have a column that represents 7 years in the future. All right, now here's how you do these problems here. You got to read them in pieces. It says Carrie is 9 years older than Dan. Ladies and gentlemen, the way this is worded here, Carrie's age depends upon Dan's age. Because of that, you let X be equal to Dan. I'm going to show you something that's very important in general for all word problems. You might want to write this down and highlight this. In general, for all word problems, this is what you want to remember. If some quantity A depends on some quantity B, then what you want to do always is you want to let X be equal to B, not A, but B. This is very important in general. It helps you to better understand how to declare your variable or variable expressions. If some quantity A depends upon some quantity B, based on how the word problem is worded, then you want to always let X be equal to B, not A. Let X be equal to B. So make sure you just document that and highlight that. This is true for all word problems in general, okay? All right. Now let's get back to our problem here. It says in number 20, if Carrie's age is 9 years older than Dan, ladies and gentlemen, Carrie's age depends upon Dan's age because Carrie's age is before Dan in the first sentence. Because of that, we're going to let X be equal to whose age? Dan's or Carrie's? Dan's age. So therefore, we're going to let Dan be X years old right now, today, in the present. But if Dan is presently X years old, it says Carrie presently is 9 years older than Dan. How do you represent 9 years older than X? X plus 9. Is this making sense here so far?
Yes.
All right. Now it says, now we go into the second sentence. It says, in 7 years, oh, wait a minute, slam on the brakes. In 7 years, ladies and gentlemen, how old will Dan be in 7 years if Dan is X years old today? Do you agree in 7 years, then Dan will be what, X plus 7 years old?
93.
No. Dan is presently X years old
Oh.
right now. In 7 years, do you agree then he will be X plus 7 years old? He'll be 7 years older. Does that make sense?
Yeah, 'cause you adding the 7 years.
That's right. But ladies and gentlemen, Carrie today, right now, is X plus 9 years old. Carrie in 7 years will also be 7 years older. So in a variable expression that represents Carrie's age 7 years from now is going to be her present age, which is X plus 9, plus how many more years? How many more years?
7.
7 more years. So do you agree a variable expression that represents Carrie's age 7 years from now will be X plus what? 16? Isn't that true? Carrie will be X plus 16 years old 7 years from now. All right, let's go back and read this now. I got to read that second sentence again. It says in 7 years, the sum of their ages will be 93. So look at 7 years from now, Dan will be X plus 7 years old and Carrie will be X plus 16 years old. But it says in 7 years, the sum of these ages. What do we have to do to these ages here? What does it mean to sum these ages up?
Add.
Add them. You take Carrie's age 7 years from now and add it to Dan's age 7 years from now. And it says the sum of those ages must be 93. Ladies and gentlemen, there's your equation. We got to solve for X now. Combining like terms, 1X plus 1X is 2X. What's 16 plus 7? 16 added to 7.
23.
Plus a 23, and that's equal to 93. Now, how do we solve for X? Separate variable terms from constant terms. Let's move this 23 over to the right side by subtracting it from both sides. 23's drop out on the left side, isolating our variable term 2X. 93 minus 23 on the right is 70. Now to solve for X, to get X all by itself, we have to divide both sides by 2. And therefore we get X is equal to 35. What was X? What did X represent? Go back to your table. What was X? It was whose age now?
And
Dan's present age. This is Dan's age now. This is how old he is right now. What's Carrie's age right now? Oh, we have a name for that. It's called X plus 9. If Dan is 35 years old, if X is 35, Carrie's 9 years older than X. So that'll be what? 35 plus 9. And so Carrie is presently how old?
44.
And we got our answers. You got the ages of both these people right now. Dan is 35 and Carrie is presently 44. Whoops, that's called an age problem, ladies and gentlemen, a classic age problem. Okay. All right, that's a classic age problem. Let's see if we can maybe do another one, maybe. That was like number 20. All right, let's do 22. Notice in this problem, they don't exactly fill the table out as much as they filled it out in the last problem. So they're leaving you hang a little bit more on your own in 22. Let's see if we can populate this table. It says Justin is 2 years older than Ethan. That's right now, today. In 9 years, the sum of their ages will be 30. Find the age of each boy right now. Well, we have 2 rows for our table. We have Justin versus Ethan. All right, so we got 2 rows in our table. Our columns are going to be what? Now versus what's the other column? In 9 years, correct? So we got now versus 9 years in the future. All right, so let's try to populate this table here. I'm going to try to do this here. Notice, let's read that first sentence again. It says Justin is 2 years older than Ethan. Based on how that sentence is constructed, whose age depends upon whose age? Does Justin's age depend upon Ethan, or does Ethan's age depend upon Justin's? Anybody want to weigh in on that?
Just age, just one.
Yeah, it looks like Justin's age depends upon what? Ethan's age. That being the case, ladies and gentlemen, let X be equal to Ethan's present age. So yeah, Ethan is X years old right now, but it says Justin is 2 years older than Ethan's age. How do you represent 2 years older than X? 2 years older than X. How do you write it as a variable expression?
X plus
The
2.
X plus 2?
X plus 2 then would be a variable expression to represent how old Justin is right now. Okay. All right, let's go back now. It says in 9 years, oh, hold on, stop right there. In 9 years, wait a minute, how old is Ethan going to be 9 years from now if presently he's X years old? What do I put here? What kind of an expression?
X plus 9.
X plus 9. Ethan will be 9 years older than he is today. In 9 years, Justin's going to be 9 years older than his present age, which is X plus 2. So his age 9 years from now is going to be his present age plus 9 more years, which means Ethan is going to be X plus 11 years old 9 years from now. What does it say we do with these ages 9 years in the future? It says in 9 years, the sum of their ages will be 30. So what we got to do is we got to add these ages together 9 years from now. There's Justin's age 9 years from now, added to Ethan's age 9 years from now. It says the sum of their ages 9 years from now better be what, 30? There's your equation. We now got to solve for X. Combining like terms to simplify the left side, 1x plus 1x is 2x, 11 plus 9 add up to what, 20? Separating variable terms on the left versus constants on the right has me subtracting 20 from both sides. 20s drop out on the left, leaving you with 2x. And 30 take away 20 on the right is what, 10. Now we divide both sides by what to get x by itself? By 2, and we get x is 5. What was 5 again? What was x?
Ethan's age
Ethan's age when? 9 years from now or now?
now.
That's Ethan's present age. That's how old Ethan is now. Okay. How old is the other boy now? Well, the other boy is 2 years older than Ethan. So what's 2 years more than x? What's x plus 2 then? 5 plus 2, or the other boy is 7 years old. This is Ethan. This is Justin's age presently. And we're done. We have the age of those two boys presently. Ethan is 5 years old now, and Justin is 7 years old now. We're done with that word problem. Are these word problems, are they kind of like making any sort of sense here, Liz? How we're navigating through them?
Yes.
With more of these done, they start to come into focus. All right. Let's look at 26. Oh no, you know what? 26 doesn't give us a table now. Does that mean we're basically out of luck?
No.
No, it means we're gonna have to build our own table. So we're gonna build our own table for 26. It says John is 4 times as old as Martha. Okay, let's have 2 rows for our table. The first row, maybe we'll call John. The second row, we'll call Martha. Okay. All right, so we got 2 rows in our table. All right, now we got to figure out what we're going to label our columns in our table. So what I got so far is this. I got 2 rows in my table, John and Martha. Let's go back now. It says John is 4 times as old as Martha. 5 years ago. Hold on. All right, now we're talking about not in the future, but we're talking in the past. So our columns are going to be now and 5 years ago. 5 years ago. These are going to be our columns. Okay, so now we have our table coming into existence here. All right, let's read it again because I forgot it already. So you're gonna have to read these several times. Don't feel bad if you do. It says John is 4 times as old as Martha. What do I let X be equal to, ladies and gentlemen? John's age or Martha's age? What do we let?
Martha.
Martha's age, yes, because John's age depends upon Martha's age, the way it's worded here. Let's let X be equal to Martha's present age. Put X in here. That's how old Martha is right now, X years old. But what did it say about John's present age? It says John is 4 times as old as Martha's present age. How do I represent 4 times Martha's age of X? How do I write that as a variable expression? 4 times X, just 4X. That's how old John is right now. Let's go back and read this again now. It says in five years ago, oh, wait, stop there. 5 years ago, how old was Martha 5 years ago if she's presently X years old? What variable expression do I put in here to represent 5 years ago?
X minus 5.
Martha was X minus 5 years ago, five years ago, correct? If she's presently X years old, that was her age 5 years ago. Well, John was also 5 years younger 5 years ago. This is his present age. So 5 years ago, this was John's age.
Or X minus 5.
That makes sense. That was his age 5 years ago. What does it say we do with these ages though, 5 years ago? Oh, it says 5 years ago, the sum of their ages was 50. We got to add their ages together 5 years ago. Take John's age, add it to Martha's age 5 years ago, and it said the sum was 50. You have your equation now. We got to solve for X. Combining like terms, 4X plus 1X is 5X. A negative 5, what's a negative 5 minus 5?
1.
No. What's negative 5? Subtract 5, ladies and gentlemen. That's the same thing as negative 5 plus a negative 5. What's a negative 5 plus a negative 5?
Negative 10.
Negative 10. So negative 5 minus 5 is minus 10. And that's equal to what? 50. All right, now we solve for X. Let's separate the variable terms from the constant terms. So we'll add 10 to both sides to move the 10 over to the right. Now we want to get X by itself by dividing both sides by 5. Then we get 1X, or X is equal to what's 60 divided by 5? You can use a basic calculator if you want. 60 divided by 5, or you can divide 5 into 16 manually. You're always welcome, to do this manually. And we get 12. What was X again? I forgot. It was whose age?
Martha's.
Martha's present age. Martha is 12 years old. This is Martha's age, okay? This is how old Martha is right now. John presently is 4 times older than Martha. So John is 4 times X, or 4 times 12 years. So John is 48 years old. This is John's present age, and I think we're done. We have our answers because we have the age of these 2 people now, okay? Martha's 12 and John's 48 today, right now. That's a classic age problem. These are age problems here, all right? All right, so this is being recorded, like I said, so if you miss anything, obviously we have to go back and, check out the recording. All right, so those are classic age problems there. What other type of problems have we got in here? Well, we got a couple of like geometry problems in here. That I wanted to kind of demonstrate some geometry problems. Problem number 32 I will do, one like 32. Now, because they're geometry problems, you can always draw a picture. That helps. Okay, you don't always have to use a table. Sometimes word problems warrant that we draw a picture. It says in number 32, it says the perimeter of a square is 84 meters. First of all, do we know what a square looks like? Well, a square really belongs to the quadrilateral family, ladies and gentlemen. It means it has 4 sides. Quad means 4. So we draw the picture of a square. That helps. Let's read on here again. Number 32. It says the perimeter of a square is 84 meters. Find the length of one side of the square. Now, we don't know the length of one side of the square. That's what they're asking us to find. Because of that, we need to declare it as a variable. Let's just say let x be equal to the length of a side for this square, okay? So now we have a name for the side of our square. It's called x. But what is true about all the sides of the square, ladies and gentlemen, as far as their lengths are concerned? Anybody?
Equal.
They're all equal. So if this side has a length of x, this side is of length x meters, this is x meters long, this is x meters long, because squares are like that. They have all equal length sides. All right, so all the sides have a length of x meters. Now they're saying something about perimeter. Does anybody know what the perimeter of a geometric shape is? What is the perimeter?
The total area.
Not area. It's not area. It's the total, but it is the total. It's the total distance. It's the total distance around a geometric shape. Okay, so in other words, if you picture this as being a building, we're going to walk all the way around this building. Ladies and gentlemen, the distance we walk around this building is called the perimeter of the building. Okay, so how do you think we're going to, determine the perimeter of this square here? What are we going to do with all these side lengths here of x?
Add them.
We're going to add them all together. We walk x meters, and we walk an additional x meters, an additional x meters, an additional x meters. So the perimeter of this square is going to have us what? Adding all these sides up. X plus x meters plus x meters plus x meters. That gives us the total distance around this square here, okay? Total distance around. But what did it say about the perimeter? I think they gave us something about the perimeter. Did they not indicate problem 32 that the perimeter of the square is 84 meters? They tell us that. And so since we know the perimeter of our square is 84 meters, then we should be able to say that x meters plus x meters plus x meters plus x meters is equal to what? 84 meters. It's understood these are meters. I'm not actually putting M in for meters, but these are meters. Okay, they're not inches, they're not feet, they're not kilometers or yards. Okay, they're meters. Now, how do we solve for x here to get the length of one, the length of a side of our square? We got to combine all these like terms. So what's 1x plus 1x plus 1x plus 1x? It gives you 4x. And now what we do to solve for x is divide both sides by 4. And we get x is equal to what? 4 divides into 84 how many times?
21.
21 times, ladies and gentlemen. So therefore, the length of this square side is 21 meters. You might want to put M for meters. All right, units are very important in the sciences. So make sure in the end you do put M for meters. If you just say 21, that could be anything. That could be 21 miles, 21 yards, 21 light years, okay? Put M for meters so we know what it is. And we're done with that problem. Does that make sense how we found the length of the side of this square? They all have a length of 21 meters. That is the length of the side. And when you add 21 up 4 times or multiply 21 by 4, you have a perimeter of 84 meters all the way around. That's a classic square problem. All right. Okay. That one's done. One like number 34. It says one side of a triangle is half the longest side. The third side of a triangle is 10 meters less than the longest side. The perimeter is 45 meters. Find the length of all 3 sides of this triangle. All right, since it's a triangle, we're going to try to draw a picture of a triangle. Okay, so now I have a picture, ladies and gentlemen, of a triangle, problem 34.
Can I ask what made you draw the triangle like that?
Well, I don't know. I mean, It sounds to me like all these sides do not have the same length. Okay, so I don't know. I mean, I probably wouldn't want to draw a triangle that might be what, an equilateral triangle. Do you agree where all the sides are the same length?
Okay.
I don't think that's appropriate for this problem.
Okay.
So I just decided to just, kind of draw a triangle where it kind of looks like the sides have slight, different lengths here. Okay. Kind of like different lengths. All right, so let's read on again here. It says one side of a triangle is half the longest side. The third side is 10 meters less than the longest side. I got a question for you. Very important question. What are we going to let X be equal to? Which side? Based on how these two sentences read, do you agree it says one side depends upon the longest side and the third side depends upon the longest side? Ladies and gentlemen, since that's the case, what are we going to let X be equal to? What length? What side?
The longest side.
The longest
Side.
side. The longest side. That's it. That's a key. That's a very important key to this word problem. Very important part of the word problem. So since both these other sides depend upon the longest side, we're going to start off this word problem by saying let X be equal to the length of the longest side. Now, which side looks like the longest side in my triangle? It kind of looks maybe like this one. Do you agree? I'm going to call that my side X here. All right. So that's the length of this side. X, was it inches or meters, or what were the units they were using in this thing?
Meters.
Meters. Okay, so my long side is X meters long. Now let's read this first sentence again. It says one side of the triangle is half the longest side. How do I represent half of my longest side X? How do I write that as a variable expression? Half of X. How do you write that?
1/2 X.
1/2 X. 1/2 X means 1/2 of X, or 1/2 times X. This will be the length of, I don't know, length of other side, I guess. It's some other side. All right, so that's the length of some other side of our triangle.
So it's saying the other side is half of it, or it's saying it's times it?
Well, to say that we have like half of a number, like if I have the number 10, if I say half of 10, what would that mean to do in your mind? If I said half of 10,
Divide.
well, you could do that. You can look at this one of two ways. If I said half of 10, you could take 10 and divide it by 2. Or, ladies and gentlemen, that's saying the same thing as taking 1/2 times 10. Saying the same thing. Half of 10 is 1/2 times 10, or 10 divided by 2. They both mean the same thing. So I could have also represented this as what? X over 2. Do you agree? X divided by 2. I decided to call it 1/2 X though. 1/2 times X. All right, instead of X divided by 2. If you want to represent it as X divided by 2, you can do that. It's still the same thing though. All right, let's read on here. It says, the third side is 10 meters less than the longest side. How do I, for the third side, represent 10 meters less than X? How do I write 10 less than X?
X minus 10.
X minus 10. So X minus 10 is a variable expression that represents the length of what side?
The other side.
Yeah, I think they call, wait, I think they call that the third side, correct? The length of the third side. All right, there we go. So I'll tell you what, I'm going to call maybe this side the 1/2 X length side, and I'll call this one maybe the X minus 10 length side. All right. This was by far one of the most important parts of this word problem. It's called your declaration part of your word problem, where you declare your sides as variable or variable expressions. Declaration part. Very important to get that right, because if you don't get your declaration right, if you don't declare your sides correctly, the rest of your efforts in the word problem, they're not going to be correct. You're going to have errors. So your declaration part is very important. Now it says the perimeter of this triangle is 45 meters. What does it mean to find the perimeter of this triangle? What do we got to do? Perimeter.
The distance around the.
The total distance around. And what does it mean to total up the distance? The total distance means to add all these sides up. So we'll take the length of this side, the longest side, which is X meters, add to it the length of the other side, which is 1/2 x meters long, add it to the third side with length, which is x minus 10 meters long. And they told us the perimeter was what? What was that again? Was it 45?
Yes.
There's our equation now. We have to solve for x. All right, so we got to add these up here. We got to combine our like terms here. Ladies and gentlemen, what's 1 plus 1/2 plus 1? What's 1 plus 1/2 plus 1?
2.5.
2.5. Do you agree all these x's add up to what? 2.5 minus our 10 equals 45. But you know something? It's very awkward to leave this written as 2.5. Could you help me turn this into an improper fraction? I go 2 times 2 is 4. 4 plus 1 is what? 5 over what? 2? 5/2? Another name for 2.5? How do I solve for x now? Help me solve for x. Add what? Add 10 to both sides?
Yep.
Yeah.
10's drop on the left, leaving you with 5/2 x equal to 55 on the right side. Now, how do we get x by itself here? How do we get rid of this 5/2 here?
Divide.
Yeah, technically, I mean, we would divide both sides by 5/2. Now, when you divide your right side by 5/2, you might want to write it as 55 divided by what? 5/2. These 5/2 reduce out to 1, and 1 times x is x. I will continue the problem of the year. So we got x is equal to, now how do we divide 55 by 5/2? We change division to multiplication and we flip the second fraction upside down. So 55 times what? 2/5? How do we do this now? 55 times 2/5. How would you do this?
You can reduce.
Don't you multiply right across them?
Yep, some of you are going to do this different ways. Some of you might want to multiply the 55 and 2 together and place that over 5 and then reduce. Some of you might want to employ cross cancellation here. 5 divides on itself once, goes into 55 11 times. That's up to you. I don't care how you multiply these together, but we got to get them multiplied together and get the correct answer here. Suppose we did multiply across here, 55 times 2. Well, you can either multiply the 55 by the 2 immediately, or you can kind of leave it in factored form. Leaving it in a factored form probably would be to your advantage, because you should be able to see that 55 reduces over 5, does it not? 55 reduces over 5?
Yep.
I mean, you know, 5 divides into itself once and goes into 55, divides into 55 11 times. And what's 11 times 2 now?
22.
22 meters. Suppose you multiplied the 55 by the 2. Well, if you did that, you'd have 110 over 5. But then you got to reduce this. Do you agree? You got to reduce 110 over 5. Now you could start to reduce it down by 5. 5 goes into 110, 22 times, I believe. 22 times. And 5 divides into itself 1 time. So do you agree we get the same answer anyways?
Yep.
All right, so x is 22, ladies and gentlemen. So look at this side has a length of 22 meters. What's the length of this side then? 22 minus 10? Remember, x was 22, right? We just found x to be 22. We got to find the other two sides. The other side is x minus 10, correct? That's the length of the third side. That's going to be x minus 10, or 22 minus 10, which is what, 12?
Yep.
This side has a length of 12 meters, and we got one more side. 1/2 times x. 1/2 times 22.
Oh, wait, time.
Or what's 1/2 times 22? Or what's 22 divided by 2? Same thing. It's what, 11? And we're done. We have the lengths of all 3 sides of our triangle. 11 meters, 12 meters, 22 meters. And we're done. We found all those lengths of those sides of the triangle. So once you find x, don't stop. You got to find your other sides, this side length and this side length. You got 3 different sides here. Don't just give one side. They want all 3 sides. Okay, the lengths of all 3 sides. All right. All right, that's a perimeter problem involving a triangle. Let's see here. Number 38. The width of a rectangle is 3 feet less than the length. The perimeter is 10 feet. Find the length and the width of this rectangle. This is a classic rectangle problem. So we'll draw a picture of a rectangle. A rectangle, like a square, is a quadrilateral. It has 4 sides. But unlike a square, the lengths of the rectangle are not all the same. So let me draw a picture of a rectangle. There's a rectangle. Just try to read the problem again. It says the width of a rectangle is 3 feet less than the length. What depends upon what, based on how this is structured, this sentence? Width depends upon length, or length depends upon width? What do you think?
The width of the length.
Width depends upon length. Therefore, what are we going to let x be equal to? The length or the width?
The length.
Length. Very important part of this word problem. Otherwise, if you don't start off on the right foot, you're going to get into trouble. Let's let x be equal to the length of the rectangle. Now we have a name for the length. It's called x. Normally your length is longer than your width. So I'll call these sides of length x. Let's read that again. But what was the width? How did the width depend upon the length? It says the width of a rectangle is 3 feet less than the length. How do you represent 3 feet less than the length x? How do you write 3 less than x?
X minus 3.
X minus 3, therefore, is a variable expression that represents the width of our rectangle. X minus 3 units wide, X minus 3 units wide. I think it was feet. So our length is X feet long. Our width is X minus 3 feet long. All right, what are we going to do with this problem now? We got to read on. Now that we properly declared our lengths, let's read on. It says the perimeter is 72 inches. Oh, I'm sorry, wrong problem. Number 38. The perimeter is 10 feet. How do we find the perimeter of a rectangle? How do we find the perimeter?
Add.
Add them.
We add all the sides together. So we're going to add this side to this side to this side length to this side length, and we're going to set that sum equal to 10 feet because that's what they told us the perimeter was. So we're going to take x plus, we're going to walk, let's say we walk around counterclockwise like this. So we have x plus x minus 3 plus this side length, which is x, plus this side length, which is x minus 3. And we're going to set that equal to 10. That's the equation we have to solve for x now. What's 1x plus 1x plus 1x plus 1x as we combine all these like terms of x?
4x.
4x. What's a negative 3 minus 3? Negative 3 subtract 3. Negative 3 subtract 3.
Negative 6.
That'll be negative 3 plus a negative 3, which is negative 6. So we say minus 6. The 3's combined to give us minus 6. And that's equal to 10. How do we solve for x now? Add 6 to both sides. That takes the constant 6 over to the right side to join the constant 10. 10 plus 6 is 16. Now we've separated our variable terms on the left side versus constants on the right. We divide both sides by 4 now. And ladies and gentlemen, you got your answer for x. X is equal to 4. I believe the units were feet, correct? So x is 4 feet. Are we done? Did we answer this question? Well, they wanted the length and the width. 4 feet is the what? What do we call x? It was the, this is the length of the rectangle. We want the width. What's the width? We got a name for it. It's called x minus 3 up here. So the width is x minus 3, which means 4 minus 3, which means 1 foot. This is your width. And we're done. We have the width of a rectangle and we have the length. That's what your author wanted you to find. The length and the width of that rectangle. So it's a 1 foot by 4 foot rectangle. Everybody see how we negotiated that problem there? So your declaration part of your word problem is very important. You need to declare your unknowns properly. If you don't declare these properly, then there could be a lot of trouble in your word problem. So a lot of practice, ladies and gentlemen, in declaring your unknowns properly by doing a lot of word problems. It's very important to get that right because that is a make or break situation right back up here, the declaration part of your word problem. All right, that's a classic rectangle problem there. Anything else here? Oh, there's just a couple more problems. These are coin problems involving money. Okay, let's try to do like number 44 here, and they give us a table to help us organize our information. Kendra has, how do we interpret this here? $2 and what, 75 cents? Technically, ladies and gentlemen, we know that is $2.75, but you know how you would technically read that? You would read it as 2 7/500ths of a dollar. 2 7/500ths of a dollar. In our minds, we know that to be $2.75 though, okay? Notice this total amount of money is made possible by so many dimes and nickels. If she has twice as many dimes as she has nickels, how many of each coin does she have? I have a question for you, ladies and gentlemen. Notice the second sentence says she has twice as many dimes as nickels. So the number of dimes depends upon the number of what? Nickels. Do you agree? Being the case, what are we going to let X be equal to? The number of dimes or nickels?
Nickels.
Nickels. Everybody see that, ladies and gentlemen? You're going to let X be equal to the number of nickels that Kendra has. Because if Kendra has X nickels, then she must have twice as many dimes. How do you represent twice the number of nickels, which is the number of dimes? Isn't it 2 times X? Yeah, because it says she has twice as many dimes as nickels. She has 2 times more dimes than she has nickels. Well, if she has X nickels, that must mean she must have 2 times X dimes. If she had, let's say X was 3. If she had 3 nickels, she would have to have 2 times 3 or 6 dimes. She has twice as many dimes as nickels. Okay, so she has X nickels and 2X dimes. Now you also have to bring in the monetary aspect of this problem. What's the value in cents of our nickels? How many cents is 1 nickel worth? Cents, not dollars. I said cents. 5 cents. If I said how many dollars is 1 nickel worth, you would say 500ths of a dollar, 0.05. That's the value of a nickel in terms of dollars, but they want it in terms of cents. So a nickel is 5 cents. That's why I got the 5 here. So if she has X nickels and she has what? The value of each nickel is 5 cents, then she has totally from nickels, what? 5 times X cents. Does that make sense? No pun intended. If she has X nickels, ladies and gentlemen, she has 5 times X cents. It does make sense. There's that word again. It makes, how shall I say it? It sounds right. If you have 1 nickel, you have 5 times 1 or you have 5 cents. If you have 2 nickels, if X is 2, you have 5 times 2 or you have 10 cents. If she has 3 nickels, if X is 3, you have 5 times 3 or 15 cents. It seems right. I don't know if you got 2X dimes, what's an expression, a variable expression that represents the amount of cents she has from 2X dimes? What am I going to put here in the table for the value of dimes?
10 cents.
Well, each dime is valued at 10 cents. Do you agree?
Mm-hmm.
But how many dimes does she have?
Oh.
She has 2X dimes, correct?
Yeah.
If she has 2X dimes and each dime is valued at 10 cents, what would be a variable expression that represents the amount of cents she has from her dimes, her 2X dimes? She has 2X dimes. and each dime is valued at 10 cents. Do you agree? So ladies and gentlemen, the amount of cents she has from her 2x dimes would be 10 cents per dime times how many dimes?
2.
2x dimes. That's the amount of cents she has from her dimes. She has 2x dimes. In other words, if she had 5 dimes, she would have 10 times 5 or 50 cents. If she had 10 dimes, she would have 10 times 10 or 100 cents. Ladies and gentlemen, she's got 2x dimes, each one valued at 10 cents. So therefore, the total amount of cents she gets from 2x dimes is 10 cents per dime times 2x dimes. What are we going to do with all these values of monies here? What was the total amount of money she had? $2.75. But ladies and gentlemen, that's dollars. Our values are in cents. These are not in dollars, these are in cents. So what we got to do is we have to convert the total value, which is given to us as $2.75. We got to convert it into cents. So what would this be in cents? If you got $2.75, how many pennies would you have, ladies and gentlemen, totally?
275.
You would have 275 pennies or 275 cents. Do you agree? Therefore, you must convert this to 275 cents because these amounts are in cents. You cannot deal with cents and dollars. It's like comparing apples and oranges. It doesn't work. So here's our equation. If you take the total value from the nickels in cents, which is 5x cents, and add it to the total cents she has from her dimes, which is 10 times 2x cents, you better get the total amount of cents she has, which is 275 cents. Does that seem reasonable that that would be your equation there? That's your equation. We got to solve for x now. What's 10 times 2x?
20x.
What's 5x plus 20x? 25x. Now we'll divide both sides by what? 25. And what she's going to have here, ladies and gentlemen, she's going to have x is equal to what's 275 divided by 25. Golly, I don't know. I may have to what? Maybe do some long division. Let's see. 25 divides into 27 one time with what? 2 left over?
11.
25 divides into 25 11 times. Well, excuse me, one time. 0 remainder. Answer is 11. So x is equal to 11. What was x again? I completely forgot. What is x? What does x represent?
Nickels.
Is that the cents from our nickels or the total number of nickels she has? He has. I forget who it was. He, she. I think this is the total what? Number of nickels, is it not? So ladies and gentlemen, this person has 11 nickels. And how many dimes do they have? They have 2 times that number of dimes. They got 2 times 11 or 22 dimes. Now we know how many nickels and dimes this person has. And I think that's what they were asking for, correct? The number of nickels and dimes. Let's see. Is that what they were asking for?
Yeah.
How many of each coin does she have? There you go. She has 11 nickels and she has 22 dimes. That's a classic money problem there. So that was number 44.
That was rough.
Okay. Look at this one. Maybe we should try one more here. We'll call this one for the road, ladies and gentlemen, number 50. Mary Jo has $3.90 worth of nickels. This is dollars, 3 90 hundredths of a dollar. How much cents does Mary Jo have? If she has $3.90, how much total cents does she have?
390.
390 pennies. Isn't that true? 390 cents. Okay, she has 390 cents worth of nickels, dimes, and quarters. The number of nickels is 3 more than the number of dimes. The number of quarters is 7 more than the number of dimes. Ladies and gentlemen, because the number of nickels depends upon the number of dimes and the number of quarters depends upon the number of dimes, what are you going to let x be equal to? the number of what? Dimes. Very important that you start this word problem that way. So you got to let X be equal to the number of dimes. All right. So if she has X dimes, ladies and gentlemen, how many nickels does she have if she has 3 more than the number of dimes?
Say it again.
If she has X dimes, and she has 3 more nickels than dimes, what's an expression that represents the number of dimes?
3 plus X or X plus 3.
You are correct. Nickels, dimes, and quarters. I'm making my table here. Okay, so we got nickels, dimes, and quarters, and we got the number of those coins versus the value. It says that she has what? X dimes, but she has 3 more nickels than dimes. How do you represent 3 more than the number of dimes X? You said X plus 3. You are correct. That's the number of nickels she has, X plus 3 nickels. Let's read on. It says, oh, but the number of quarters she has is 7 more than the number of dimes. How do you represent 7 more than the number of dimes X? How do you write
X
that as a
plus
variable?
7.
Yep, X plus 7 is a variable expression that represents the number of quarters she has. X equals the number of dimes. X plus 3 is a variable expression that represents the number of nickels. And X plus 7 is a variable expression that represents the number of what? Quarters. We have declared our unknowns properly. If we have, ladies and gentlemen, if we have X dimes, how much cents do we get from X dimes? Each dime is valued at 10 cents. If we have X of those dimes, how much cents do we have? What variable expression represents the total amount of cents we get from X dimes?
10X.
10X, you are correct. That's the total amount of cents you get from X dimes. If she has X plus 3 nickels, each nickel being valued at 5 cents, how much total cents does she have from X plus 3 nickels? 5 cents per nickel times how many nickels? X plus 3. That's the total amount of cents she has from all her nickels, or X plus 3 nickels. Each quarter is valued at 25 cents a piece. We have X plus 7 quarters. What's a variable expression that represents the total cents from all our quarters?
25 parentheses X plus 7.
You got it. So if she has X plus 7 quarters, totally she has 25 times X plus 7 cents from the quarters. How much cents did she have totally? What was the opening?
390.
390 cents. So ladies and gentlemen, if I take the cents from the nickels, which is this, add it to the total cents from the dimes, which is this, add it to the total cents from the quarters, which is this, these better sum up to all the cents she has totally, which is 390 cents. There is your equation we now solve for X. So how do we solve this equation for X? We're going to have to what? Distribute here and here. What's 5 times X?
5X.
What's 5 times 3?
15.
Good. What's 25 times X? And what's 25 times 7?
175.
175. All right, back on the left side, we got a lot of simplifying to do. What's 5X plus 10X plus 25X? 5 plus 10 is 15. 15 plus 25 is what, 40? We got 40X. All of our X-like terms combined to give us 40X. Combining our constant terms, what's 15 plus 175? 15 added to 175.
190.
190. I believe it's 190.
Yep.
And now we got our equation down to this. To solve for X now, we separate the variable from the constant terms, subtract the 190 from both sides. 190 drops out on the left side to 0, leaving us with 40X. 390 take away 190 is 200. And now to solve for X, we divide both sides by 40. Then we get X is equal to what, 5?
Yeah.
What was X again? I forgot. Oh, X was the number of what? Dimes? She has 5 dimes. How many nickels does she have? X plus 3 nickels? So she has X plus 3 or 5 plus 3 or what? 8 nickels? And ladies and gentlemen, finally, how many quarters does she have? X plus 7 quarters? She has X plus 7 quarters or what? 5 plus 7 or 12 quarters? And we're done. We know how many coins of each she has. 5 dimes, 8 nickels, and 12 quarters. Ooh, that is a classic problem involving nickels, dimes, and quarters. All right, I've gone over every type of problem that I want to show you here, ladies and gentlemen. All you have to give me is just your classwork number 1. Okay, I don't have any time left for any other classworks here, so just classwork 1. There you go. This is being recorded, so you'll have the luxury of being able to watch this whole thing all over again with maybe a bowl of popcorn later on. Do you agree? All righty. All right, so that's it, ladies and gentlemen. I'm going to let you go. You have a great night. Have a great weekend. And I'll stay on the line if there's any other further questions or issues. Okay.
Thank you.
We'll see you.